The series of short videos cover property predictions of chemical system. First, in the series, we will start with pure component properties predictions of organic chemicals and polymer lipid units. The second, we will cover mixture properties of organic chemicals. And the third, we will cover on the predictions of inorganic salt in aqueous electrolyte system, phase diagram of non-reactive reactive system, and also solubilities. Properties, as we know, play a very important role in the process as well as product synthesis, design, analysis, and applications. In this video, after a short introduction on the role of the properties, we will highlight the computationals of the pure component properties in 4 steps. So, let us get started. Nowadays, the demand for a better and more diversified chemical product is continuously growing. Therefore, research and development team in industry, academia, and research institution team are busy with finding a way to improve existing product and their manufacturing processes, or developing new, better, and more sustainable alternatives. The operational conditions of most operation processing load are defined temperatures, pressures, or compositions of the chemical system handled in them. The feasibilities of operations depends on the properties of chemical system as the functions of this variable. However, before the properties of mixtures of chemical system can be calculated, pure component properties of each chemical needs to be known. Therefore, in this video, we will illustrate the computationals of some important pure component properties. We classify the pure component properties into 2 types, primary or single value properties and the functional properties. Every chemical compound has 1 properties for each primary properties. For example, critical properties like critical temperatures, critical pressures, and critical volume, normal boiling point, normal melting point, and so on. Functional properties are those that change as functions of temperatures or pressures. For example, the change of enthalpy of the liquids or vapor as the functions of temperatures, the heat of vaporizations as the functions of temperatures, or the change of density as the functions of the pressures. Basically, use of experimental measurement is an obvious first choice. However, this will require not only very large database to cover all properties, but it's also practically impossible to measure all necessary properties. Consequently, models for important properties have been developed to help engineers, researchers, students, and many more to quickly, consistently, and reliably access the needed properties value, so that they can effectively solve the various product and process-related problems. We will assume that the viewers know the basic theories of the thermodynamics properties. If not, please check the recorded video from the PC-SAFT webinar series 2021, Webinar 2 on properties predictions. In this properties prediction series, we will mainly use ProCAPE, which is our especially developed computer-aided properties estimation software tool. ProCAPE consists of 9 main functions, which are properties model validations, model generations, database managers, molecular structures, properties estimation for pure components, property estimation for mixtures, and for solid solvent analysis. In this video, we focus on the features for the properties of pure components, and we will use the pure function in ProCAPE. The PL's toolbox of ProCAPE calculates properties based on our group contribution-based property methods, such as the Marerro-Gani method, the Constantinou-Gani method, and their latest update. Estimations of primary properties, secondary properties, which are the function of primary properties, functional properties, and environmental properties, which are also primary properties, will be highlighted. In addition, features in pure related to data fitting, generation of small or group atom conductivities, thermodynamic diagrams, property data plots, use of PC-SAFT for temperature pressure dependent properties, as well as our latest machine learning based model for primary properties will be also highlighted. PL guides the user for property estimation through 4 simple steps. First, launch the property estimation toolbox, then give the chemical compound molecular data. Here there are 2 options available. Give the SMI data or draw the molecular structures. Next, estimate the properties which are almost immediately shown on the results section. And finally, view and copy the properties for export to author system. We will now walk you through the conceptual step through the demonstration of the main feature of PL.
4 steps are needed for the estimation. Firstly, launch the property estimation, and there are 2 options on adding the chemical compounds, using the smile or drawing the structure here. And then the property will be estimated and user can view primary, secondary, functional, and environmental properties. Moreover, there are functions available for user to further calculate the properties that are data fitting, batch smile, for the searching a lot of smile in the same time, thermodynamic diagram, data plot, PC-SAFT, and machine learning based on the primary properties. Okay, then turn back to the demonstration again to show on how to estimate the property using the different compounds.
Okay, so as Orgot have described, the property estimation of here is available in here. So this tool will calculate the property of pure compound based on the several models, no matter the Marerro-Gani Wilson method, along with other interesting models. So pure can predict many compounds which didn't find in any other sort, and software also eliminate a problem that user don't know a compound name because pure use a compound structure as an input file. Moreover, it also supports the data fitting tool for fitting the functional property and the graph plotting for the fragment and the thermodynamic properties. The main interface is separate in 3 parts. The first part is drawing interface at the right-hand side, which is used for specify the compound, and the property is interface at the right-hand side for show the properties. And then at the top one will be the shortcut tool that user can access every single feature that available in this function. And the software is allow user to perform the compound by inserting smile or draw the molecular structure. First, user can define the compound by inserting smile by right-clicking here, click import smile. And let's say if I would like to import hexane and click OK. Then I will click search database. And it will find that, okay, this structure is hexane compound. And then the property will be shown at the left-hand side. User can draw the molecule directly in case user only know the molecular structure. And the property have 3 sections, which have both estimated and experimental property. First is the primary property in here as a main property that user usually find. And next is secondary property, which is the additional property. And lastly is the functional property, which will depending on the temperature. Furthermore, the property can be predicted through ML2 and PC-SAFT. User can estimate the property to machine learning by clicking in this button. And during this step, the model will calculate all the value. So now that is the property that was calculated by using the machine learning. Okay, and in here you can see that from the left-hand side, the experimental value, critical temperature is 507.60. And in here from the machine learning is around 507.49, which is quite close and accurate. And then for another tool, user also can predict to the PC-SAFT by clicking in here. And then all the parameters that were used for calculation are shown. And then click OK. And all the property in each temperature will be calculated. And we can take this value to use to plot the figure. But before I will click plot, I will select the type of plot like the saturated pressure and the heat of vaporization, and then click plot in here. So as you can see in here, okay, so as you can see in here, the saturated pressure will come up with the temperature and the heat of vaporization will come down with the temperature. We can indicate the critical temperature by looking at the point that heat of vaporization is close to 0. And as you can see, TC from here is also quite similar with the experimental data that I have shown before. Okay, and then I will close all. Also in here, we can change the atom type in the structure that I have import. In here, I will try to change this atom from carbon to oxygen, let's say. And now we got the OH group and it showed that, okay, this compound is 1-pentanol. Okay, and the 1-pentanol have 3C around 586.15. Okay, then I will click ML to let it calculate at the same. Okay, so in here you can see that the value in machine learning is quite closer than the estimated value from the other model. It means that the machine learning model is very accurate for this compound. And then I will close this one and calculate through PC-SAFT again. Okay, I'm following all of the steps. And as the same as we have seen that in the experimental data, the critical temperature is around 585, which is matched with the PC-SAFT diagram in here. Okay, and we call this one. And next, I will try to create the compound that doesn't exist in any way, in anywhere, but it can physically create it. Like if I just add a branch here and more bond, one more, or I also can add the benzene ring. Okay, so now the structure have so now the structure was added with some bond, and the property in the left hand side, it will be predicted following along with the change of structure that I have added. So primary, secondary, and functional property are given. Also, there is a feature for the data fitting. So for example, if I would like to build a correlation and corresponding property of the vapor pressure in here, I will just click data fitting. And then I will quickly go through step like next, and then select vapor pressure like this, and next, and select the on-tone correlation to fit with the vapor pressure, and then click fit. And then the plot figure is given along with the on-tone parameter at the bottom. There are also so many property and correlation in the software that are available for user to do the data fitting in here. And if there is no data in the left-hand side, it cannot be fit by PL, but we also allow user to give the data manually and use the data fitting feature along with the data that user already have. And next, I will call this one. Another interesting feature is thermodynamic diagram. In this feature, the thermodynamic diagram 5 types can be generated. So it will be the relationship between the condition like pressure or temperature, along with the thermodynamic property like the enthalpy, the entropy, or the specific volume. For example, if I select pH in here and click show plot, now the figure between the enthalpy and pressure of selected compound will be plotted, and the data will be given in here. Okay, so I will close this one. And next, in PL, user also can define the compound by drawing the molecule. So I will just create the new one, let's say, and then I will try to generate the polymer compound. So first, I will just add a benzene ring at the head and the tail. Okay, then same as before, the property will be shown at the left-hand side, and there are also have multiple models that user can select and see the result depending on the preferable. And also there are the model for the polymer compound and lipid compound. But since I still didn't make this one as a polymer, so the tab for the polymer result still not available now. Next, I will try to make it become polymer by add the here and another one here. And next, since it still be a carbon atom, I will just change atom type to R group. And then with another side also. Okay, so now you will see that the tab for the polymer is viable and the properties are predicted in this corresponding table.
We hope you got an idea of the step of the Pion's component properties estimation through this video. If you would like to know more, the manual of Pion gives information on all the features available and highlights their use through worked out tutorials. Please contact us or visit our website for more details on ProCAPE. And please subscribe to our YouTube channel to remain updated on our newest additions to the PC for Speed YouTube channel. Thank you for your time and interest on our videos.